Today's video is over. Compare and order rational numbers. What are rational numbers again? Rational numbers are any numbers that can be written as a fraction or a ratio, A over B. Whole numbers can be written as a fraction. Integers can be written as a fraction. Decimals can be written as a fraction. So, let's answer this question. Do now. Winona is 2 and 3/12 the height of her little brother. Express this mixed number as a decimal. So I see a fractional part right here. You can say that's 3 divided by 12. You have 3, you're dividing it into 12 parts. 3 divided by 12 parts. In case you forget, because some people forget, use Tybo. Top number goes in, bottom number goes out. Can 12 go into 3? No. 0 times. Add a 0.0. Again, it does not change its value. Bring down to 0. How many groups of 12 go into 30? 2 times. 30 minus 24 is 6. Add another 0. Bring it down. How many groups of 12 go into 65 times? So the decimal 3/12 is equal to 2,500. Remember from elementary school, 2 and 3/12 is the same as saying 2 plus 3/12. 2 plus 2,500 adds up to 2 and 2,500. Did you know you can simplify 3/12 to 1/4? And 1/4 is equivalent to 2,500 or 3/12. So again, as a reminder, to convert a fraction to a decimal, because if you can do that, this whole lesson is just turning all fractions to decimal. Use the word Tybo, top in, bottom out. Again, you have 3, you're dividing into 4 parts, 3 divided by 4, or 3 divided into 4 parts. And that's equal to 7,500. Let's start with the first one. This is the number line. In the number line, it goes from least to greatest. So we're going to have -1, -half, 0, 1/2, and 1. If you have half, or you have 1, you're dividing it into 2 parts. $1 divided into 2 parts is 50 cents. So the decimal equivalency is 50 cents. So -1/2 is -50 cents. This is -1. If you want to, you can write -1.00, and 1 whole is 1.00. So let's begin the first one. Find the equivalent decimal and plot on the number lines. We're going to go back and plot it on here. So let's start with our first one. We have 7/20. You can say that as 7 divided by 20. 7 divided into 20 parts. Or use Tybo, top number goes in, bottom goes out. Can 20 go in 7? I don't think so, 0 times. How do I get rid of this remainder? Add a 0.0 right here. Again, it does not change its value. It's still 7 divided by 20. Bring it down. How many groups of 20 go into 70? 3 times. Remainder is 10. Add another 0. Bring it down. How many groups of 20 go 100? 5 times. And we are done. So it's 3,500. So let's click on this. What was the fraction again? 7/20 is equal to 3,500. So it goes 3,500, 7/20. 3,500 is less than 50 hundredths, but more than 0. Next question. 7/8. You can write that as 7 divided by 8. Or you can say 7 divided into 8 parts. Can 8 go in 7? I don't think so. 0 time. Remainder 7. I need to get rid of this remainder. So I add a 0.0. Bring it down. How many groups of 7 go into 80? 8 groups. 70 minus 64 is 6. Add another 0. Get rid of this remainder. How many groups of 8 go into 60? 7 groups. That's 56. 60 minus 56 is 4. I need to get rid of this remainder. Add another 0. Bring it down. How many groups of 8 go into 40? 5 times. So the decimal equivalency to 7/8 or 7 divided by 8 is 875 thousandths. Where would it go here? Well, it's positive 875,000. If you want to, you can add extra 0, so that's all the thousands. So 350,000, 500,000. So that means 875,000 is between 500 thousandths and 1 whole. That's 7/8. Or another way, some people actually round 875,000 to 88 hundredths. Next one, 5/6. That's 5 divided into 6 parts. Can a group of 6 go to 5? 0 times. How do I get rid of this remainder? At a point 0. Does not change its value. Can 6 go in 50? 8 times. 50 minus 48 is 2. I need to get rid of this remainder. How many groups is 6 going to 20? 3 groups. Remainder is 2. I need to get rid of this remainder. How many groups is 6 going to 20? 3 times. Hold up. It's like deja vu. This is repeating. Oh, it's those repeating bars. So we could say 833,000 repeating, or you could say 8,300 repeating bar. So let's go back to our number line. It's 833,000, so that would be going right before 875,000. It's 5-6. Next one, 4/11. That's the same as saying 4 divided by 11. So you have 4, you're dividing into 11 parts. Can group of 11 go to 4? 0 times. How do you get rid of this remainder? Add a point 0. It does not change its value. How many groups of 11 go to 40? 3 times. That's 33. 40 minus 33 is 7. Get rid of this remainder. How many groups of 11 go to 70? 6 times. That's 4. Get rid of this remainder. Add another 0. How many groups of 11 go to 40? 3 times. That's 7. Hold up. I think it's deja vu again. It's repeating. 6 times again. It is repeating. So you could say 363,000, put a bar. Or you, right here. Or you could say 3,600 repeating bar. Which number is repeating over this quotient? The 36. So I'll put a bar over the 36. So let's go back and look back at where would this go? Let's see, it was 3636. If you round it, it's 363. So it go right here, and that's 3,600 or thousands. So that was 411. What about any negative numbers? How come we haven't touched the negative numbers? Don't worry about that. That's coming up right now. You have negative 1/5. That's negative 1 divided into 5 parts. So you have 1 divided by 5 parts. If you want to, put the negative sign right there. So how many groups of 5 go in 1? 0 times. Again, it does not change its value as 0.0. How many groups of 5 go in 10? 2 times. So we have, and 0 times. 0, so it's negative 20 hundredths. So negative 20. Remember, in the number line, you're counting backward. So this 50, so it'll be 60, 70, so 20 would go right somewhere right here. And our last answer, last rational number is negative 11 divided by 20. So use 11 divided into 20 parts. Can a group of 20 go in 11? I don't think so. 0 times. I need to get rid of this remainder at a point 0. It doesn't change its value. How many groups of 20 go in 110? 5 times. Remainder is 10 and there's 0. How many groups of 20 go in 100? 5 times. So we have negative 55 hundredths. Let's go back and guess where it is. So we 20, but you're counting backward. So it must be somewhere right here. So the question in here says the following. Using a number line, put these rational numbers in order from least to greatest. It is right here. So we have first one, negative 1120. Negative 1/5. 7/20. 4/11. 5/6. And lastly, 7/8. And those are from least to greatest. Let's do a real world question where you might see this. The NFL keeps statistics for each professional football player. Their statistics determine these players' salary and playing time. The more you produce, the more you earn and play. If you are looking for Mr. Joe on the Houston Texans list, he gave him his professional football career after a foot injury to be your math teacher. When he was doing the Gangnam Style, He slipped, he slipped and broke his foot. The sacrifice he made to be your teacher. Hey, I'm even wearing a shirt, see? My former jersey with them. See, I took off my name off my back. So Arian Foster is 3,700 is his average. 3/10. That's 3 divided by 10. What is the decimal equivalency of it? It's 0.30 hundredths or 0.3 tenths. J.J. Watt is 3,800, 1750. That's 17 divided by 50. 250 parts. 0. It goes in 3 times. And get rid of the remainder. So it goes in 34 hundredths. What about 8/25 or 8 divided by 25? It goes in 3 times, which is 75. 5 is the remainder. Let's get rid of the remainder. Goes in 2 times. That's 32 hundredths. And last but not least, you have 1/3. We've done 1/3 before. Do you still remember? It's repeating 33 hundredths. So putting them from greatest to least. The highest, of course, is JJ. He's the highest paid player. Then is Arian. And then you have DeAndre with 34 hundredths. Then you have let's just call him Clowney. No, that's a great name, isn't it? And then you have Brian C. Cushing with 3,200 and Brian Hoyer, the quarterback. I think he's I can't remember if he's just backup or the starting. So again, how do you put rational numbers in order? Turn them all into decimals, and if you need to, draw a number line, put them from least to greatest, and you'll have it.